So, hello guys, and like you probably know, today we're talking about design patterns in microservice architecture. So, before we begin, let me introduce myself. So, I am a lead software developer working at the software house. I'm working mostly in PHP, but I'm also messing around with other technologies and architectures. You can find me on Twitter, LinkedIn, and probably many other different platforms behind the nickname Edic. If you want also to start some more in-depth discussion of any of these topics that I will be mentioning, there is my email address, so feel free to ping me. Okay, so today we will be covering a few different topics. We will focus on the patterns, solutions, and approaches which could be used to create a system in a microservice architecture. Okay. Okay, yeah. So let's go to the basics because I get the information that you didn't see the slides. So again, design patterns in microservice architecture, that's me. And today we will be covering the basics, communication, internal communication, security, availability, configuration, and logging when it comes to the microservices. With all the things and hype around awesomeness of the microservices, the main question is, should I use microservices? Probably not. And the reason for that is simple. The number of systems where microservice architecture is a good fit is simply quite low. So maybe let's start from the basics and see what's hiding behind the microservice term. So what is a microservice? Microservice architecture is an architectural style in which application is created from collection of services. And these services should have all the characteristics specific to such architecture. And first of all, they should be loosely coupled. That means that each service should be running in its own process and communicating through some kind of lightweight mechanism. They also should be independently deployable. So what it means that any of these services could be deployed at any time, probably by some kind of automated CI or CD. Such approach also should provide high maintainability and testability. And also each microservice should be built around one specific business capability, and in best case scenario owned by a small dedicated team. But the question is, should you start with the microservices right away? Maybe the architecture is the best fit when you know that your application will be very complex and at the same time require high scalability with rapid and frequent delivery. But of course, this is pretty awesome, but everything comes with a cost. So what are the drawbacks of microservices? So first of all, if we are going for the microservice architecture, then we are running distributed system. And running distributed system is very hard because we have no single instance of the applications. So it's very hard to debug, monitor, and even difficult to orchestrate. Also, maintaining consistency is very challenging because when we have contract between the services, keeping it consistent between all the related instances may be difficult. Also, what you need to know is that ops complexity is very high. And what I mean by that is that you need a very big amount of the resources from your ops department because the setup and maintaining such a complex architecture is very costly and also includes usage of additional tools. Now we know the advantages and disadvantages of such architecture. So you may be uncertain if your application will need to handle huge load and will be very complex at the beginning. So should we still decide to go with the micro or maybe stick to what we know the best? And what we know the best is the monolith. When we are talking about the monolith, probably it pops in your head as some kind of different services divided in some way that are tightly connected to each other. And this is probably what we know the best from our experience. But is this the best that we can get? In the monolith, the services are probably divided in some way. When we are using the most popular frameworks, then we are probably dividing the services by the layer horizontally. And the question is, could we do it better? Because the monolith in our eyes is simply the big ball of mud. But is it specific to monolith? I think not, because we can do it better. So Simon Brown, an author of a book called Software Architecture for Developers and author of many great talks on the microservices topics, came with a simple conclusion. So if you can do a monolith with a good architecture, most probably in microservices, it won't be any different. And then we also got a big ball of mud, but distributed and raised to another complexity level. So the answer he proposed is a pattern called Modular Monolith. So briefly talking, this approach is quite simple. It combines dividing application by layers, which we are doing pretty often, with dividing by features. Then we should end up with a system that is built with blocks called components, where each component provides a single public API. This prevents the biggest problem we had with the monolith, so tight coupling, and prevents from having a huge mess in our code. And we also don't increase maintainability costs, and in future we are able to convert to microservices. So what are the biggest selling points which this approach shares with microservices? So they are both, they both have high cohesion, they are loosely coupled, they both work around bounded context, they are encapsulated, substitutable, and focused on the one single business capability. So the only difference here between our component and microservice is that public API in our component is probably some kind of access modifiers on programming language, where on the microservices, it's some kind of network protocol. So we are dealing with network boundaries. What is the biggest advantage here when it comes to the modular monolith and building your application from components is that you don't have all the drawbacks which microservices have. But of course, it can be the same as the microservice, because if you need, for example, individually deployable, upgradable, replicable, scalable, and use different languages in your application as a whole, then only microservices would allow you to do that. But if you don't need those characteristics, then probably the modular monolith may be a better way to start your application than going straight to the microservices. But the question is, can we go even further? So the modular monolith may be a good approach to start the project, but it doesn't provide us with all the benefits like I just mentioned. So should we then jump straight into the micro? Maybe, but there's also something in between, and it's called self-contained systems. So self-contained system is an approach to architecture which focuses on separation of the functionality in many independent systems. And we are making the complete logic system out of that components by using a collaboration, most in the best case scenario, on the UI level. So that is also different from the microservices because the self-contained systems are like small building blocks which are separated from each other. They can work together, but they, the part where the integration is implemented is the UI. So the characteristic of the self-contained systems is that each system is autonomous. Each is owned probably by one team, but this, of course, there may be some exceptions. Also, STS can have optional API, which is of course optional because in the best scenario, UI is our way to go. Each STS, of course, have its own data and logic. And then the most important is that we are avoiding coupling on the business logic level wherever is possible. What this approach gives us is that we have really separated systems which combined together creates our whole application. You may hear of something called micro frontends because it's quite popular or even hype word nowadays. And this is pretty much the same approach. They may differ in some kind of details, but this is pretty much the same approach for creating the applications. So when we have self-contained system, why we didn't choose to go with the micro? So these both approaches share similar concepts because they are both enforcing isolation. They support diversity in terms of technologies, and they lack of centralized infrastructure. But the biggest difference, like I already mentioned, is that the integration on the STS is going on the UI level, and at the best case scenario, STS should not communicate with each other, where for the microservices it's quite common and is okay. Okay, so this may be a good fit for application if you require diversity in terms of technology, but also didn't want to jump straight into the microservices because you couldn't handle the complex infrastructure at the beginning. So this might be good to go, and moving from the STS to the micro should be pretty simple. Okay, so let's go with another topic, which is communication. So there are many different ways when it comes to the communication between the microservices, and the most simple one is direct communication. So in this case, our client must know which services are there and under what physical address they are accessible. The problem is here that we may have different protocols on our microservices, and we are not sure how to communicate with them. Our client would need to support all kinds of different protocols in itself. This could be problematic and very hard to maintain. So are there better solutions? Yes, and the first pattern to solve the problem is called gateway. In this case, the API gateway is single entry point for our clients, and the API gateway handles all the translation between our client and different protocols, but also it handles the communication between the services. The problem here is that we might introduce some kind of single point of failure, but in most cases, that shouldn't be any problem. Example of the client using the API gateway may be Netflix. What is also good when it comes to the API gateways is that if you have monolith and want to transition to the microservices, then you can put the API gateway in front of your monolith and then route the request either to the monolith or to your new microservice which you just created when you have them ready and up. Okay, so there's also another approach, maybe even variation about the gateway, and it's called Backend For Frontend. And in this approach, we also have API gateways, which are our BFFs. And the difference here is that each gateway is dedicated for one type of client. So in this example, we have web application and mobile application, in which case they both have separate gateways. What it gives us is that the methods inside of our gateway and the data returned to the client may be completely different and dedicated only for single type of applications. So we don't need to send a huge amount of data for our mobile application where it's not needed. Okay, do we have any questions maybe? Okay, so we got a question from Krzysztof. He asked, should logging events debug data be a separate service? If it depends how to decide which approach is better, what tools to use to gather and analyze log files? So I probably won't answer if it's right away, because we will be talking about that later on the presentation. But pretty much, yeah, we will cover that just at the end of the presentation. Okay, we also have a question from Victor, which asks, when is it okay to have inter-service communications, and when all services should talk to each other through some entry point? Okay, so probably in most scenarios, we would like to have some kind of service between our clients and microservices. So we don't need to care about all the communication details on our client. It gives us the ability to maintain the clients very easily when we will have some kind of direct communication or nothing in between our microservices. It might be become very hard to maintain. But we will be also talking about that in a moment. Okay, so let's continue for now. So the next topic is internal communication. It's related to what you just also asked. So the first approach to the communication is usage of something called remote procedure invocation. So what are the characteristics of this approach is that this is synchronous. It's simple because we already are familiar with such approaches. It's easy to understand and probably also test or debug. And it follows simple request response, but not in our cases response, and we will talk about that in a second. So the most common implementation of the RPIs is something called REST. I am pretty sure that everyone knows what it's about because it's the most common pattern in the web. So the advantage is here that it's pretty familiar with our environment. I mean the developers here, and it's based on the HTTP. So what that gives us is simple. It's very simple to debug, test, even through some kind of extensions like Postman, or we can even do a HTTP request straight from our command line. And what is good about it also, and it's shared between probably most of these approaches, is that we have no intermediate broker here. But what we wanted to mention here is that REST is not always the answer to your problems, because there are other solutions out there, and we wanted to mention it here. So the first one is called Thrift. It's backed by Facebook. It provides us with language-neutral contract file. What this means that you have the file that is independent from the programming language in which you define your contract for the communication. And from that contract, you can generate the code in many different languages, which you can then straight use in your application. What is nice about Thrift that in difference to REST, it provides support for notifications. So we can send the request to the server, but do not get any response, where on the REST, probably the server still needs to send some kind of response. Okay, so the next approach is called something called gRPC. It is a open source API baked by Google. What is nice about this kind of communication is that calls made with gRPC are visible as internal calls in our application. So it provides better tools for developers. It's pretty much more developer friendly. It also provides us with simple contracts. So in this case, in case of gRPC, it's called proto-buffers. There are also language neutral and also provides the code generation from them to many different programming languages. Okay, so we got the gRPC, but what if we need something more advanced? And to that communication comes something called message broker and basically messaging. So it provides different kind of communication than the RPIs because it's asynchronous. It follows not request response, but publish subscribe model. The only bad thing about that is that increases complexity because we need to have additional service between our micros. And the main idea here is that we have some service which is called message broker and provides us with the possibility to publish and subscribe to certain channels. So in this example, we have the trip management microservice, which sends the publish message to our new trips channel. Then the dispatcher handles that and posts that information to our other micros, in this case, passenger and driver, because they were subscribed to our channel. There are many different softwares when it comes to the message broker. The few examples could be RabbitMQ, Kafka, Redis, or NATS. They are all pretty much open source or free to use, if I remember correctly. So you can feel free to check any of the solution. Of course, each of them may be a little bit different. So you would need to dive deep into the details of the features that they provide and see what is better for your use case. Okay, but messaging and RPI is not what we will be probably using as a single solution in our applications, because the most common scenario is that we need some kind of both of these approaches in our applications. So the most common is that we use combined messaging. What it means that we use RPIs when they are better fit, and we use message brokers where we need some kind of publish and subscribe model. Okay, so when we are done with the messaging, let's jump into the security. So there are many different approaches to the security, but it's probably not the easiest topic when it comes to the microservices. But the simplest solution we have is no security at all. So this is pretty obvious, but it's simple. You have no overhead, but the bad thing is that it's very rarely possible, because in most cases, you want to have some kind of security in your application. The second approach is to have our ACL in every microservice. And it's not the best solution because we have duplication of our ACL logic, users management, and some kind of stuff from this world. And we also redistribute our ACL across all microservices, and we introduce context mixing because our microservice then is not only dealing with the business capability that it was designed to do, but also this to some extent with the ACL logic. So the next approach is having our ACL as dependent microservice. So in this approach, we extract the ACL logic as a separate microservice to which we can communicate from other micros. So it is good because now we have ACL defined as a single microservice with encapsulated logic. We prevent duplication and redistribution of our ACL logic between all of our microservices. The bad thing here is that it could be a single point of failure. So the next approach is having ACL on the gateway. So this may be a few variations on the topic, but we may have ACL straight on the gateway, or also implemented ACL as a microservice to which our gateway will communicate to.
So the good thing here is that we have no duplicated ACL logic in none of our microservices. We have no huge overhead, and we also simplify internal communications. Because now all of our microservices then would share only one simple library to only do some basic stuff on the ACL, maybe checking through some kind of attributes, but all the ACL logic would be separated completely from the responsibility of other microservices. Okay, so the next topic is availability. And the biggest problem in microservices is that we often used the infrastructure, which is very complex, maybe deployed to some kind of Kubernetes cluster. So our microservices might be up and down, may be scaled up and down, may change locations, may change addresses. So how do we communicate? So the first important rule is that we don't want our locations to be hard-coded, because like I mentioned, nowadays, the locations of the microservices could change, and we need to somehow handle that. So first thing that may come to your mind is DNS, because it allows you to map some kind of host name to physical address of the microservice. Pretty simple, but not the best solution, as DNS balancing may be different depending on the client. And this is also not the fastest solution. So as an improvement to that, you will probably want to introduce some kind of load balancer, which could also be called as a router pattern. In this scenario, our load balancer would need to resolve and know about the microservices, the addresses. And this is good because our client then doesn't need to know all the microservices directly. They can only do requests for some kind of standardized URL, and then our router would route the request to the right microservice. But if we will have very dynamic infrastructure, this wouldn't be enough. So that's the place where the service discovery comes into play. So what is service discovery? Service discovery allows us to find the microservices that we want, and it allows us to communicate with them. So there are many different approaches for service discovery. The first one is client-side service discovery. So the thing is here is that our microservices are registering itself into the service registry, and then our client, which have some kind of HTTP client, must be aware of the existence of microservices and our service registry. Then the client would ask, before each request, it will ask the service registry about the locations of the certain microservice in order to perform the real request afterwards. And the second approach is to have server-side service discovery, and it differs from the previous because here we also introduce load balancer, and the load balancer itself handles all the resolving for us. So the load balancer is responsible for querying the service registry, and still the microservices must be somehow registered into the service registry. So the examples here of the software which allows you to have the service discovery, maybe Consul from HashiCorp, etcd, or Zookeeper. Also, what is good to mention here is that most of the solutions does provide service registry, but not only that. So you must, again, see what here will be the better fit for your case, but we will talk about one of them more in depth in a moment. Okay, when it comes to the registration of our microservices into the service registry, there are also two approaches. So the first one is self-registration, So in this case, our microservice is registering itself into the service registry, doing some kind of heartbeat and unregistration afterwards. The second approach is different because it's third-party registration. And what we have here is introduction of third-party service, which is a register in this case. And the register here is responsible for monitoring the health of our microservices and registering or unregistering it into our service registry. What is important here that the registrar probably would be using some kind of health check. So it's important to have the health checks implemented on our microservices. Okay, so going straight to the example. So the Consul is one of the service registry that we mentioned, but it doesn't provide only service registry. It also supports health checking out of the box. It provides us with key value storage. It provides us with secure communication because it generates the TTL certificates itself for us. And probably the most important when we have complex infrastructure is that it supports multiple data centers out of the box. So that shouldn't be a problem when it comes for using Consul. Okay, so the next thing is what you should do with the failures. And in our opinion, you should handle the failures. What it means? In our microservice architecture, many things could fail. And as our architecture is built from multiple pieces, those pieces, more than one piece could fail at the time. So we need to define network timeouts to prevent some kind of long lasting request that may time out for the user. We also need to limit number of outstanding requests. And we also should provide fallbacks. And what I mean by that is that if you have some kind of service which where responses could be cached, then we should probably do that because in case of our microservice going down, other services could still work properly when they will receive the cached response from that microservice. What also you should implement in your application to assure that you have good availability is something called circuit breaker. So sometimes when handling requests on which multiple services need to collaborate, something could go wrong. So let me go straight to the example. So let's say we have some kind of payment microservice, and we have third-party client. So the payment went through for the user, we got our request, all was correct, but now we need to ping our client, third-party endpoint, that everything was okay, you don't need to worry about anything. Okay, so we send the request, and nothing is going on, timeout. What should we do then? So that's what circuit breaker defines is that we should have some kind of rules for failing. So in this scenario, let's say the first request which was sent straight away when we receive the event in our systems, then we will fail, wait, let's say 1 minute, retry. If it fails again, we wait 3 minutes, retry. If it fails, we wait 4 minutes, retry. So if we reach some kind of certain number of failed requests, then we can fail the whole request for the user and just drop the request so we can fail in a very good manner. So what it gives us also is that when one of our micros is down, then we can just redo the request and assure the consistency, and then all the requests in our application are handled. It also prevents the fails on our internal communication to do not cascade. So when one service is down and we are inside a circuit breaker, it prevents us from DDoSing our application when this certain microservice would come back to life. Okay, so the next topic is configuration, but before that, do we have any questions? Okay, so we got a question from Jacek. So the API gateway is responsible for checking whether a token is valid or not. How other microservices know that the request comes from API gateway and is not direct request to the REST API of the microservice? Okay, so in the approach where you have the ACL defined on the gateway, all of your microservices are into the separate network. They are only allowed to communicate with each other. So basically, you are creating some sort of in network calling the militarized zone. So no external request may come to your microservice directly, or request must go to the API gateway. So yeah, this is answer to your question. And another one is from Dimitrios, and he asked, how could a centralized ACL service know about the specific permissions that needs to be enforced in another service that are dedicated by the service's specific business model? Isn't that mixing the responsibilities of the services? Okay, so it may be also related to the configuration that we will be talking in a moment. But answering your question is that if we have ACL as separate microservice, that ACL would provide some kind of tools for managing users, managing roles, managing attributes. So it would only do that. And then you probably would get a JWT token on the microservice. And on the microservice level, you can check whether some kind of required attribute for your business context is there or not. So I don't know if that answered your question, but this is pretty much the solution when it comes to that approach. Okay, so let's get further. Okay, so do we have any other question? Okay, so we also get a question from Kvid, and he asked, if the container orchestration tool provides the service discovery feature, then do we still need to use third-party service discovery tool like Consul? So answering your question, probably not, because the orchestration tools are pretty complex, and they probably what they are doing. But in every case, it's good to do some kind of research, see what the tool that you're using currently enables you to do, and look for the alternatives. Of course, having less things that could break and having less complex architecture is what we want to have. So if you don't need external service discovery tool, then you probably don't want to go for one. Okay, so let's get back to the configuration. So important thing when it comes to the configuration is that we want to have our configuration externalized. So what it means, so that we can have separate config file completely from our microservice. So if we are setting up our microservice on our infrastructure, then only on the setup level, we are passing the configuration file to the microservice, but nothing in our microservice itself is hard-coded. And I will go later to the one example. But like you can see here, we also have the configuration separated into different sections. This is worth mentioning because we also believe in approach we call one configuration to rule them all. So basically what you have is one configuration file divided into the multiple sections. And what the sections allow you to do is that if you spin up microservice A, then you can pass to it only, let's say, part of the configuration from section A. So our microservice would receive only the configuration which is relevant for them, not the whole picture. But what having the one configuration file for all our microservices is that we have one source of truth, like snapshot from our system. So it allows us to have simpler debugging because we don't need to figure out what was the configuration of the different services. But if we have some kind of trouble on the production, then we can go to our ops department, ask them, guys, we have some kind of problem. We need to have a snapshot of our configuration to figure it out. Then they can give you the whole configuration of all of your microservices in one single file. So basically, we are having one configuration, and on run of each microservice, we are cutting down the configuration only to the relevant part and passing in through to the microservice. Of course, how you implement that depends on your use case. This is only one example of doing such. Important thing is that we have the configuration completely externalized, and only relevant configuration is passed to the microservice. Okay, so next topic is logging, or maybe more accurate tracing when it comes to the distributed systems. So the question is how to debug microservices. So in order to debug microservices, you should probably aggregate all logs in a single place. Of course, there are many tools to allow you for such use case. You should also track exceptions which happens in your application. And the most important, you should trace the request, because logging here would be probably enough. Okay, so when we have logs, when we track all our exceptions, what we can do there is visualize. Why we should visualize is if we visualize, then we can have simpler debugging, resolve the problems more quickly, and basically they give us more insight into our workings of our application. So one tool which allows us to do the tracing of the request and also to some extent visualization is called JAEGER. It's a tool written in Go. It provides us with ready-to-use libraries which we could implement in our microservices. And then the request would be traced through our whole system. So if our request would go through 4 microservices, then we could see all of the route here. So we know what happened on what microservice, how long it took, and stuff like that. So it's very helpful because if you wanted to look at it from logs, it would be very complex because the time differences may not be that accurate in order to say which request on which microservice was first. Okay, so what you should also do is that you should measure, because if you measure things, then you can visualize things. And like we said, visualizing things could improve the debugging process. But having some kind of monitoring on our application is also good, because acting on the details we have on the monitoring, we can introduce auto-scaling or even more complex solutions related to the CI or CD. So what you should measure, of course, differs depending on the application type. The most obvious ones are the execution time of queries, request execution time, number of requests per minute, responses time, success failure ratio, and resources usage. The example here of such tool which allow us to monitor our application is called Prometheus. It is an open source system, of course, providing us the monitoring, but also alert toolkit, so we can integrate it, for example, with Slack or other tools. And it's built originally at SoundCloud. What is important here that we can also visualize the data that we receive from Prometheus. And here you can see one tool that is called Grafana. So basically, here we have example of the Grafana diagrams created based on the data from the Prometheus. This is also a free tool, so you can use it anywhere, and you can use it based on many kinds of data. So it's not only limited for use with the Prometheus, but you can use it with whatever you want. Okay, so now we can do the microservices the right way, or at least we know the approaches, their advantages and disadvantages, and to which direction we should go. But the question is, can we do them fast? And in our opinion, you can do the microservices fast, but you need to follow two rules. So the first one is define standards or contracts. So don't be scared of defining some kind of standard or contract for communication. And I'm talking here about many different things. This could be contract for communication, but not only. We can also, for example, standardize the directory structure of our microservices. And this is important because when we have standards defined, then we can go to the second rule, which is embrace tooling. So when we have standards, then we can build our tooling on top of that. So one example here is service structure generation. So we have standard for structure in our microservices. Then we build a tool which allows us for generating such kind of structure. So it's speeding up not only our creation of new microservices, but also improves the developers' familiarity across different microservices. And the other example could be related to the communication protocols. In this case is gRPC. So on the left we can see which is the contract for the gRPC. And from that we can generate the code into different languages and just use it in our microservices. Here we have, for example, defined service, messaging service in gRPC protobuffer. And from that, we could simply generate the code interface for reuse in our microservice. So the bullet points here are define contracts, don't be afraid to define standards, and try to build a tooling around that, which will allow you to progress faster when it comes to the microservices. But also one important thing is how to organize microservices in code repositories. So there are two approaches when it comes to the repositories. And the first one is called multi-repository. So the good thing here is that we have better owner separation. And what I mean here is that each repository could be owned only by a single team. So two teams are completely separated from each other. And what is good here is also that we have a clear scope, because straight by looking at the repository name, we already know what is his purpose, and we don't need to think what it may have inside there. The bad thing here is that it's hard to keep consistency here, because we need to version our application, and it could become very complex when we have some kind of contract shared between few of our microservices. There is also a risk of this approach for becoming a monolith, because then if we need to jump between different repositories, it may be very tempting to introduce some logic which should land into the different microservice. It also introduces more CI and CD setup, because of course we must have each setup for each repository. The second approach is called monorepository, and the good thing about that is that it's easy to maintain consistency. So as we have everything in one repository, if we change contract, it's changed across all of our microservices right away. And it's easier to version such approach, because there also we have everything in one place. So if we push one version, everything is up to date and consistent. The disadvantages here is that different teams may affect each other. So let's imagine that our one team breaks something that basically stops the CI from running. Also, the other teams are affected by that. It also may lead to tight coupling, because when we have the services lift one under each other into the repository structure, then it might be tempting to create a strong coupling between the microservices. And the last thing is that we will have longer bit times, because, okay, we don't have multiple CIs, but then we need to fetch all the code in every case. In one of our projects, we decided to go with the monorepository, and why is that it provides us with better consistency and easier versioning, but also it's better because in our case we have we don't have dedicated teams for each of the microservices, so few developers could work on few microservices. So having it completely separated into different repositories may be just very confusing and very hard for developers to work with such solution. Okay, so what's important here is to say what we didn't cover today. So we didn't cover databases, testing, CI/CD as essential tool. We didn't cover destructive testing, deployments, and many, many more topics. We only talk about the most important things into the microservice architecture. I think I would imagine for myself that I, in some extent, help you to decide in which way you should go with your application. But of course, for everything, there is no single bullet. So on a few of these topics, we already had a webinar, so we can jump into it. But summing it up, what's important to get from that webinar is think twice if you really need a microservice architecture, because it is not a good fit for every project. You also need to ensure that you have all necessary resources to operate distributed systems, because it introduces very complex infrastructure design for your ops department, and make a code and educated guesses, decisions, what is best for your case. So don't follow blindly the solutions that are under your nose, but do some basic research and see which tool may be better, or which approach, which pattern may be better in your case, because you are probably not the Netflix. You don't need to deal with so huge amount of traffic and don't need such huge scalability. So research what is best for you, not others. And also what is important is don't be afraid to define contracts, define standards, and embrace tooling around that to speed up your development process. Okay, so here are a few resources that was used on that webinar, but they are also much deeper on itself. So if you have time, feel free to dive deep into them. They are very good resources, so we highly recommend that. And that would be pretty much for today. Thank you for coming for our webinar. Hopefully you will get something out of it. And that's all.